Hello. I would like to do one of the IB 2023 questions. This is problem number 11 from Mathematics AI, paper 1 and 2023. And the question reads like this. So two AC alternating current electrical sources of equal frequencies are combined. The voltage of the source is modeled by the equation V equals 30 sine of t plus 60 degrees. And the voltage of the second source is modeled by the equation V equals 60 sine t plus 10 degrees. Determine the maximum voltage of the combined sources, and then using the graphic display calculator, find a suitable equation for the combined voltages. Given your answer from in the form V equals V naught sine AT plus B, where AB and V naught are constants. All right. So this is a trig question. And one of the things I noticed right away is that we're in degree mode. So in your calculator, you're going to want to make sure that you know how to get into degree mode. So if we go to mode, and so if you're in radian, make sure that you're able to turn it into degree. You know how to quit. Okay, so what I'm going to do is just join or combine these two voltage equations together. So V is equal to, and what is it, 30 sine t plus 60. And then the combine is going to be a plus. Plus 60 sine of t plus 10. Okay. So we'll go to the graphing calculator, and I think we'll go ahead and just plug those in. I've already done so. And I think an appropriate window, well, if you think about the largest that a sine can be, like sine of 90 degrees, for instance, is equal to 1, then I think the very maximum, since we're looking for a maximum, determine the maximum voltage. The maximum should be no bigger than 30 plus 60 or 90. So that would be possibly our max. This is a sine function, so it could also be a minimum. So going down to y min, 90 minus 90, let's open it up a little bit more and say negative 100 is y min, and y max is 100. And of course, the default period for sine and cosine is 360 degrees. So I'm going to do one full period to the left, negative 360, one full period to the right, positive 360. And I'm going to make my hash marks 90 degrees each. And that's kind of default or by default. So we'll go ahead and graph. And it looks like this. So I'm going to sketch that graph. Maybe I'll put it over here. So I'm going to sketch that graph. And I'm going to label some important parts, like for part A, I am interested in the maximum. And turns out I'm also going to be interested in the minimum just to check it. So I'm going to check this also on the calculator. So let's go to the calculator to find a maximum. So I can calculate, find a max, and I'll find that max right there. I mean, this graph looks just like a very symmetric sine function. And so I'm assuming that this max is going to be the same as this max over here, and that they'll all be the same. And so what I found is at 63 degrees that my maximum is 82.5. And let's check the minimum just to make sure. Minimum as well. And it's negative 82.5. All right, so it looks very symmetric, negative 82.5. And that can, of course, speak to the amplitude of this sine function. So determine the maximum voltage. I'm going to say the maximum voltage is 82.5. All right, that's our maximum voltage. So that should answer question A. All right. So part B now says, using your graphics display calculator, find a suitable equation for the combined voltages, giving your answer in the form V naught sine AT plus B, where A, B, and V naught are constants. And A must be positive, all right? And B must be positive and no bigger than 180 degrees. All right. I think what I'm going to do is try to come up with an equation. And here's, for part B, here's what they've recommended. V equals V naught sine of A T and plus B. So in order to find the equation, there's a few of these constants that we still need to find. I feel like we've already found V naught because that's our maximum. That's our amplitude. That is 82.5. Sine of. Okay, so now let's see if we can find this value right here. This one has is a frequency and it has to do with calculating our period. So let's look at our graph and see if we can find our period. And so I'll just find a couple of points that I think could help me to determine the period. I'll go to the midline and going up to the midline, and then here is one whole period later. So I'm going to find both of those values using my graphics display calculator. All right. So let me find a couple of zeros. So we'll go to 0, and I'm closer to this one, so I'll find that 0, left bound, right bound, and 333.8, we'll say. So that is 333.8. It's right there. All right. So let's find another 0. And this one's going to be even more significant. This 0 is also going to help us with a phase shift. So left bound, right bound, and negative 26.2. Negative 26.2 degrees. I should put degrees on there. That is that point right there. All right. So if I take the 338.8 and I subtract a negative 26.2 degrees, we get 33.8. The minus a negative is really a plus 26.2. 333.8 plus 26.2 is equal to 360 degrees. So that's our period. Our period is equal to 360 degrees, and you should recall that that is the default period for the sine function. So if that's the case, then this A has to be a 1. And a 1 makes this problem a bit easier. A 1t and plus. Now here's my phase shift. So this is a sine function, so I know that the sine is going to start on the midline, starts on the origin, and this phase shift of 26.2 degrees to the left is kind of like sliding the y-axis over to the left 26.2 degrees. So it's like I have a virtual starting point or a virtual y-axis. And so minus a negative, well, this is 26.2 degrees. So if I add 26.2, that's going to make it go to the left. And I've already actually shown that my midline is equal to 0, like it's not gone up or down. And so let's see, using your graphics display calculator, find suitable equation for the combined voltages. And it looks like V naught is equal to 82.5. A is equal to 1. And this B is equal to 26.2. So let me rewrite it one more time. 82.5 sine of 1t plus 26.2 degrees. And I found that using my graphics display calculator. And I do believe we are done. And I took my time with that question, but it should be about a 5-minute question. One thing I want to point out too, and that is the issue of the argument. So like one of the ways to solve this problem differently would be to use a little bit more calculus and solve more directly. So they're asking for a maximum. So you could have, of course, found the derivative, set the derivative equal to 0 and so on. But here's the issue. The issue is in the argument. The argument is this little bit inside of the parenthesis. I've got a t plus 60 and a t plus 10. And so those arguments are different. And so I think automatically we ought to think of solving this in the graphics display calculator. If those two arguments were the same, it would make it a lot easier for us to solve. So here's what it takes for us to solve this by hand. We have to do a derivative. We also will need to do what's called the sum identity for cosine, sum identity, and so break it out into pieces. We'll have to solve it eventually. Once we have the arguments the same, we'll have to solve it eventually for a tangent. We do the inverse tangent or the arctangent and solve, and we would be able to find the value of 63 degrees is where our maximum is. And of course, what we're really looking for is not the 63 degrees, but we're looking for the maximum of 82.5, which happens at 63 degrees. So I think because the argument is different, I think we automatically got to go to the calculator. We're allowed to use a calculator in the mathematics AI exam. And so this to me is a graphing calculator question. And also it says so in part B of number 11, using your graphics display calculator. So that's a pretty good hint, that we are going to use that calculator to solve. So thank you very much. And I hope that was helpful.